Now we're going to spend a few minutes here, and I mean just a few, wrapping up the WAN section. And I wanted to go over this material again with you. Some of it is from the ICND1 section, but I'd like you to see it again. There's some informative values in here and some speeds that we did not talk about earlier. Leased lines we definitely talked about, and I think this is the networking term that has the most other terms for it, because I know I've called them serial lines, serial links, or just, is the serial up. People call them T1s even when they're not running at T1 speed, just out of habit. T1 links, WAN links, point-to-point links, point-to-point lines, doesn't matter. They're still leased lines. Now, to get those leased lines to work in a production network, we know that the CSU DSU has got to give clocking to our router, the DTE. That CSU DSU is generally referred to just as the CSU, and collectively that DTE and the CSU make up the customer premise equipment, the CPE, because that equipment is on our premises. Now, our network may not have an external CSU. Many of today's Cisco routers actually have WICs in them that have an embedded CSU DSU. And I think I was really happy about this because one particular place I worked, I won't name because they might be listening, boy, it just seemed like the CSU was going down all the time. And I know other places it's like it just works forever. I guess when you pay for them with box tops, you get what you pay for. But that's all I'm going to say about that. But it is one less external device that can go down. Now, a little bit of acronym confusion can crawl in here. And let's clear that up. The CSU DSU is acting as a DCE. That's the data circuit terminating equipment, and also called data customer equipment on occasion. I've said that before, I've heard other people say it, but it is data circuit terminating equipment. The DCE gives a clock rate to the DTE, and in doing so, basically it's telling our router, our DTE, when to send data and how fast it can do so. So it's saying, when I say jump, you're going to say how high. Except it's really saying how fast. And of course, how fast just happens to depend on how much money we're giving the provider. Not talking badly about service providers, we all got to make a dollar, but that's just the way it is. There are 3 digital speed values you should know, since they might show up on your exams, and they will show up in one form or another during conversations with your provider. We have DSO channels. Those are 64K each. Digital signal 0. Sounds kind of ominous. And according to Wikipedia, that's enough for one digitized phone call, and that's the purpose for which this channel size was originally designed. Now, digital signal 1, those channels run at 1.544 meg, and if that sounds familiar, it's because we usually refer to DS1 lines as T1 lines. Digital signal 3 channels run at 44.736 meg, sometimes rounded up to 45 meg in sales materials and other materials. T3 lines can carry 28 DS1 channels or 672 DSO channels. Now, fortunately, we're not locked into these 3 speeds. If we need more than 64K but less than a T1 line, we can buy that speed in additional units of 64K. And since we're buying a fraction of T1 speed, that's where we get the name fractional T1. Now, we might need more speed than a T1 offers, but we don't need or want to pay for T3 speed. There's no use in paying for something you're not going to use. We can purchase additional speed in units of or channels of 1.536 meg, and that little difference there is the overhead. And it's no surprise this is fractional T3. Now, if you're looking into this on a professional level, you might want to check Wikipedia's page. Of course, there are other good sites for it as well. But there is a Wikipedia page that has the other options, including T2 lines and the international differences between the channels and their speeds. Not CCENT or CCNA material, just strictly saying that it is there. It is worth a read. EWANs versus EWOCs. I like EWANs and I don't like EWOCs. That's strictly an editorial comment. If you like them both, that's fine with me. But an EWAN, it's an Ethernet WAN. And I took this quote from Cisco's site, and of course there can be a little sales pitchy in there, but nothing wrong with that. But this is pretty accurate. Ethernet has evolved from just a LAN technology to a scalable, cost-effective, and manageable WAN solution for businesses of all sizes. Ethernet offers numerous cost and operational advantages over conventional WAN solutions. An EWAN offers robust and extremely scalable high-quality services that are superior to any traditional WAN technology. That's pretty big talk, mister. You better be ready to back it up. And actually, seems like they're doing a pretty good job with it. Now, the connection to our EWAN is really similar to connecting to our ELAN, if you will, our Ethernet LAN. You know, you're going to use an Ethernet interface to connect rather than the serial interface that we used in this section for HDLC, PPP, and frame relay WANs. And I've got a couple of links here for you, and since you're watching it on video, I'll also put those links in the description area. Of course, you can find them very quickly. There is an excellent guide out there on Cisco's site for choosing the right router and or switch for your Ethernet WAN. And of course, they have quite a good page out there for about the integrated services router as well. Again, these links aren't required reading for the exams, but it's good material to have handy when you're the one making these choices. Now, a very little about MPLS. I was a little surprised Cisco mentioned this in the CCENT and CCNA because it is a complex subject, and it's like they just don't mention it much, even in their own stuff. And you know, to me, giving someone a little MPLS, it's like saying, okay, I'm going to give you a high level view of knee surgery. You know, here's the knife, here's the knee. You know, it's like, well, we need a little more to go on than that. So I've given you a little bit more here. We're not going to get into live configs on MPLS, but I know I have this on the board as well. But this is really right now, outside of IP version 6, the #1 topic I get requests for to make a separate course on. So it's probably something I'm going to do in 2014, but more importantly for you, it's an indication that this is a good skill to learn once you are done with your CCENT and your CCNA. Let's talk a little bit about what this is, because like I said, MPLS, it is a complex topic. And where frame relay and EWANs run at layer 2, MPLS VPNs can run at layer 2 or 3. But when you hear someone mention MPLS VPN, they mean the layer 3 variety. Now, our MPLS VPN endpoints and midpoints consist of customer edge, provider edge, and provider devices, and they're all sending and forwarding IP packets to the proper destination, you know, we hope. And let me bring that up real quick right here. Again, we've got a cloud here. Your provider routers are going to be marked with a P. Those are your service provider routers. We have nothing to do with those. And they're going to be in the core of the whole thing. The provider edge routers border the core and the customer edge routers. And the customer edge routers, of course, the CE routers. If we were going from one router to another here, what we want to do is get the IP packets from one CE to another CE. But on the way, they're going to go through a PE, and then some Ps here in the cloud, and then another PE at the other edge of the cloud, and then we've got the CE at the other end. There is just a wee bit more to this process, as you would expect, but that's definitely something to save for your future studies. And again, not just if you're looking for something else to study, maybe something to specialize in down the road, studying MPLS, I think, is a really good way to go. That is the end of this physical part of the WANs, and let's go ahead and head to that next section after you take a breather. See you there.